Okay, so this is on gas laws and the mole, chemistry leaving cert question, higher level 2007, question 10b. Okay, so the first part of this question is asking us to state Avogadro's law. And Avogadro's law states that equal volumes of gases contain equal numbers of molecules under the same conditions of temperature and pressure. Now, for the second part of this question, we're told that carbon dioxide is stored under pressure in liquid form in a fire extinguisher, and 2 kilograms of carbon dioxide are released into the air as a gas on the discharge of the fire extinguisher. And we're asked, what volume does this gas occupy at a pressure of 1.01 by 10 to the 5 pascals and a temperature of 290 Kelvin. Okay. So, the first bit of key information from this question is that we're told that we have got 2 kilograms of carbon dioxide. Now, we have to be careful here because we don't actually work in kilograms very often in chemistry. We work in grams. So, for example, the molecular weight of an atom, or well, a molecule, is given in grams per mole. So we need to change this to grams. So there are 1,000 grams in a kilogram. So this means there's 2,000 grams in 2 kilograms. Now, so we have our mass of our CO2. We're told the temperature is equal to 290 Kelvin. And we're happy with that unit. We're given a unit of Kelvin, don't have to change that. We're told the pressure is equal to 1.01 by 10 to the 5 pascals. We're happy to work in pascals as well. We're looking for the volume. That's our question mark. What volume does this gas occupy when it's released from the fire extinguisher? Now, this is all the information that we're told so far. We're not told any other information. So it seems like we haven't got a huge amount for our gas equation. But we will in fact be using PV is equal to nRT from our formula and tables booklet. So we've got PV is equal to nRT. We have pressure, we're looking for volume, we don't have N, we'll be given R, and we have temperature. So R is equal to, and it can be found in our formula and tables booklet, 8.3 joules per moles per Kelvin. And we don't have the number of moles. So we've got 2 question marks here. We don't have the number of moles and we're looking for the volume. But we are given the mass of carbon dioxide. And if we're given the mass of the carbon dioxide, we can find the number of moles of carbon dioxide that we have. Now, to go from mass to moles, we need to use our molecular weight. So we've got carbon dioxide, CO2, and we can go onto the periodic table and we'll find that the atomic mass of carbon is 12, and for oxygen it's 16, and we've got 2 oxygens, so we're going to multiply that 16 by 2. So it's going to be 12 plus 32. And that's going to equal 44 grams per mole of CO2. So what this is essentially telling us is that 44 grams is equal to 1 mole. Well, what would 1 gram equal? we would divide both sides by 44. And now we're not interested in 1 gram, we're interested in 2000 grams. So now we're going to multiply both sides by 2000. And this will give us the number of moles of carbon dioxide for 2000 grams. And this is equal to 45.45 moles. Okay, so now we can fill that in here. 45.45 moles. And now, from our equation, we have the number of moles. We have ore, and we're just looking for volume. So we've got PV is equal to N or T. Volume is our question mark, so we're going to rearrange this equation for volume. So we're going to divide both sides by P, our pressure. And we can see that our pressure on the left hand side is going to cancel out, and we're going to be left with just volume. Volume is equal to N or T all divided by our pressure. Now, our number of moles was 45.45. Our N. Our ore is 8.3. And our temperature was 290 Kelvin. All divided by our pressure, which was 1.01 by 10 to the 5 pascals. Now, the really important thing to remember when using this equation is the units that we're working in. We're given Kelvin, so we don't have to change that unit. We're given pascals, we need to work in pascals. And we're going to have a final answer of volume in meters cubed when we use these units. So we have to use those units. So this is going to equal 1.08 meters cubed when we solve that. Okay, so that is the answer to the volume of carbon dioxide. What volume does this gas occupy at these conditions? So that's that answer. Now, the next part here, we're asked what mass of helium gas would occupy the same volume at the same temperature and pressure. So what mass of helium gas this time? Okay. So we're looking for the mass of the helium, and mass is measured in grams. So we're looking for a unit in grams. But we can't work directly into grams. First, we're going to have to look for the number of moles and change that into grams. So N is equal to a question mark. Our volume is equal to 1.08 meters cubed from the last question. Same volume, same temperature is equal to 290 Kelvin. Same pressure, 1.01 by 10 to the 5 pascals. And again, we're happy with our units. So we're going to be using PV is equal to N or T. We have pressure, we have volume, we don't have our number of moles, we have ore, and we have T for temperature. So we're going to rearrange this equation now for the number of moles, and when we have our number of moles, we can calculate the mass of helium. Okay. So we'll rearrange now. So N or T is equal to PV. I've just flipped that around. And now we're going to divide both sides by RT. We can see over here, our R's and RT's are going to cancel out, and we're going to be left with N is equal to PV over RT. Okay, so now we can fill in our numbers. So N is equal to PV over RT. Now our pressure was 1.01 by 10 to the 5 pascals. Our volume 1.08 meters cubed. Or is our ideal gas constant, that is still 8.3, and our temperature is 290 Kelvin. So when we solve this, we will get 45.45 moles of helium. Now, the moles, we need to now change from our moles of helium to our grams of helium. Now you may have noticed that for this part here we have got 45.45 moles of helium, and for our number of moles here we worked it out on the previous question for the number of moles of carbon dioxide, 45.45 moles of helium. So we actually didn't have to work out our number of moles here again, because this is essentially Avogadro's law. Under the same conditions of temperature and pressure, our number of moles of gas will be the same. So our number of moles of helium is the same as the number of moles under the same conditions of temperature and pressure of carbon dioxide. So the moles, now we need to change from our number of moles of helium to our grams of helium. And to go from moles to grams, we have to use our atomic mass from our periodic table. So helium has an atomic mass of 4 grams per mole. And this is telling us that 1 mole is equal to 4 grams. So then we want to work out how many moles would 45.45 moles be equal to. So we need to multiply our 4 grams by 45.45, and that's going to equal 181.28 grams. Now for part 3. Give one reason why carbon dioxide is more easily liquefied than helium. So why would carbon dioxide be more easily liquefied than helium? So if something is easier to change into a liquid, it must have stronger intermolecular forces. So we can just write that down. So CO2 has stronger intermolecular forces. And this is the case because our carbon dioxide molecule is, sorry, I've drawn that wrong. Our carbon dioxide molecule is much bigger than a helium atom. Okay, so this means that there's much stronger intermolecular forces.